Okay, we're going to be talking about Chapter 7, and we're in Section 2 where we're going to be adding and subtracting algebraic expression. So the objectives of this are going to be able to, you're going to be able to combine like terms, and you're going to be able to remove your parentheses properly when solving algebra problems. So what does combining like terms mean? If you've got two algebraic terms, they are said to be like terms if they contain exactly the same literal part. For example, we've got the 2, which is our number in the front. The x is in the back. That's our literal part. And on this one, we've got our 5, which is our numerical part, and our x in the back, which is our literal part. So these two are like terms because they have exactly the same variable raised to the same power. So another example of things that would be like terms, if we just had the numbers -2 and 3, those are like terms. If we had -2x squared and 4x squared, those are like terms because they both have a variable that is raised to the exact same power. Okay, we could say that 3x squared y and -2x squared y are like terms because they both have x squared y to the first power, x squared y to the first power. So because their variables are exactly the same and raised to the same power, they are like terms. However, if I were to put 3x squared and 4y squared, these are not like terms because this is an x and this is a y. They have to be the same variable raised to the same power. So these two would be not like terms. Okay, so you are able to combine like terms. So what you do when that happens is you put the coefficient or the numbers in the front together. If they're both positive, you would add them. If one was positive and one was negative, you would subtract them. But in this same example, we've got 3x squared and 2x. Those are not like terms because this is an x squared and this is an x, so therefore we can't add those. This is 3xy squared and 7xy squared, so we've got the same variables raised to the same power. So we could actually put those two together and say that that was 10xy squared because 3 and 7 are 10. This one's not going to work because they're not the same variable raised to the same power. You can add and subtract like terms, but not unlike terms. To add or subtract like terms, add or subtract their numerical coefficients and keep the same literal part. For example, if we want to add 2x plus 3x, we look at the terms, the variables, and make sure they're the same. They're both x raised to the first power. So we know we can take our 2 plus 3 and get 5. So that would give us 5x's. Okay, on this example down here, it says to subtract 8a squared times x minus 3a squared times x. So the first thing I want to look for is my variables and my exponents. This is an a squared times x. This is an a squared times x. Those are exactly the same. So when I subtract them, I'm going to get 5a squared x. And by doing 8 minus 3, by subtracting the coefficients, the number in the front. Okay, so on part C here, we've got 6n plus 4n squared minus 3mn, and what we want to do is see if there's anything that we can combine. So do you see another n to the first power? This one's n squared. This is n to the first, but it also has an m connected to it. So no, nothing would go with that. I've got a 4n squared. I don't have any other n squareds. That's not going to work. And this one actually is m times n. So there would have to be another term over here that had m times n for that one to work. Okay, so you can't combine like terms on that one. If a term does not have a numerical coefficient in front of it, the coefficient is 1. For example, x means 1x. Okay, and if you ever see negative x, that means negative 1x. Okay, so in general, to simplify a series of terms being added or subtracted, first group together like terms, then add or subtract. So we have an example here of 3x plus 4y minus x plus 2y plus 2x minus 8y. Okay, if you want to look and see how they work this, that's fine. I'm going to work it a little bit different than the way they have it, so I'm going to write it down here. So I've got 3x plus 4y minus x plus 2y plus 2x minus 8y. Okay, the first thing I see is that this one doesn't have a number in front of it, and so we just learned that that would be a 1 if there's no number there. So I'm going to go ahead and insert that minus 1 in front of that x. I'll make it a little bit different to work, easier to work with. Now, when I'm looking at this, I'm noticing that everything is either x to the first or y to the first. So those are going to be my like terms. I like to kind of come up with a shape or a symbol to put over all of them that are alike. So for instance, I'm going to circle all of my x's raised to the first power, and I'm going to circle the sign that goes in front of them too. So this is an x to the first, this is an x to the first, this is an x to the first, and the rest of them look like y's. So from there, what I know is I can do 3, this is a positive 3, minus 1 plus 2. So 3 minus 1 plus 2, and that's going to get me my term in front of my x raised to the first power. So 3 minus 1 is 2, and 2 plus 2 is 4. So if I combine like terms, I'm going to get 4x there. Okay, now let's look at if we combine our y's together. I'm going to put a box around those. So I've got a plus 4y, a minus 2y, and a plus 8y. Those are all y's raised to the first power. So when I combine like terms, I have a positive 4 minus 2 plus 8. So 4 minus 2 is 2. 2 plus 8 is 10. So this would be a positive 10y. Okay, so I kind of group them together like that whenever I'm combining like terms. Parentheses are used in algebra to group together terms that are to be treated as a unit. Adding and subtracting expressions usually involves working with parentheses. There are 3 main rules for removing parentheses. If a parentheses has a plus sign in front of it, simply remove the parentheses. Okay, so here's an example of that. So this is what they were saying. If it just has a plus in front of it, to work with it, you can just remove it, because really when you have a plus in front of something, it doesn't change anything. So they just remove the parentheses. Okay, here's another example of that. There's a plus in front of the parentheses here, so they just removed it. If there's just a plus, you can just remove it and work the problem from there. Okay, if the parentheses has a negative sign in front of it, change the sign of each term inside, then remove the parentheses. Okay, so remember that if you have a negative in front of your parentheses, what you're really saying is, another word for negative is the opposite. Okay, so we've talked about the distributive property before, but we want the opposite of whatever's inside our parentheses. So this negative actually has to go with both of these terms inside the parentheses. So they rewrote the 2 in the front. Then this x, it was a positive x, but because it's got a negative in front of it, it's going to become the opposite of positive x, which is going to make you have a negative x. So this is going to be the opposite of a positive 2y, which is going to get us a negative 2y. So basically, inside the parentheses, if it was positive, it became negative. And if it was negative, it would become positive. Okay, and this time we have a negative sign in front of the parentheses again, so we want to distribute it to both of these numbers inside the parentheses. Now keep in mind that when you do that, it's going to be the opposite of whatever was there. So they've taken the A and they rewrote it. Then they took the 2x and it was a positive 2x. Since there was a minus in front of it, it's going to be the opposite of 2x, which is minus 2x. We've got a negative y here, so we want to do the opposite of negative y, which is going to be a positive y, and we would write that right there. So if you have a negative sign in front of the parentheses, you make whatever is inside the parentheses the opposite of what it was. If it was positive, make it negative, and if it was negative, make it positive. Okay. In Rule 2, you are simply rewriting subtraction as addition of the opposite. However, you must add the opposite of all terms inside the parentheses. So, the third rule is needed when a multiplier is in front of the parentheses. If the parentheses has a multiplier in front, multiply each term inside the parentheses by the multiplier. Rule 3 is often called the distributive property because you are distributing the factor in front to all the terms inside the parentheses. So when we look at this example here, we've got a positive 2 that we're going to multiply by both the terms inside the parentheses. So 2 times your A gets you 2A. 2 times your B gets you 2B. And since this was a positive in between, it's going to stay positive because it's positive 2 times a positive B, which is going to give you your plus 2B here. Okay, so when we come down here, now our multiplier in the front is a negative in front of these terms. So we would do negative 2 times x, and that would get us negative 2x. Then we would do negative 2 times y, and that would be a minus 2y. So remember that when we just have a negative sign in front of the parentheses, we're simply taking both of these things and making them opposite of what they are. So we could just go straight to here. Opposite of an x, the opposite of x is going to get me negative x. The opposite of negative y is going to get me a positive y. Down here, this 2, we haven't done anything with at all. We would just write that down. The only thing that is really in front of the parentheses is the negative 5, which needs to get multiplied by both of these terms in the back. So negative 5 times 3a, okay, gets us our negative. I'm going to go straight to the answer. They've done a lot of steps in between to kind of really explain, but we're going to write the 2 down. Then we're going to do negative 5 times positive 3a. Well, that's going to get you a negative 15a. Then you're going to do negative 5 times the negative 2b. Well, a negative 5 times negative 2 is a positive 10, and then you would put the b on right here. Okay, so that would be the answer. This is the last example that we're going to work on this. If you'll notice in front of this parentheses, there's nothing there. Okay, and so in the problem they said you can just write that down, 3x minus y, if there's nothing there. Now remember, we've got the minus 2 in front of the x and in front of the minus 2y. So negative 2 times a positive x, negative 2 times a positive x is going to get me negative 2x. Negative 2 times our negative 2y is going to get me, well, a negative 2 times a negative 2 is going to be positive 4y. Okay, now the last step that we talked about at the beginning of the lesson would be to combine any terms that are alike. So I'm looking at this and I'm going to put circles on my x's. So I see a 3x, and you always put the sign with it that goes with it, and I've got a minus 2x. Those are like terms because they're both x's raised to the first power. So I can put those two together. 3 take away 2 is going to be 1x. Okay, and then I've got I'm going to put boxes around my y's, but I've got a minus y and I've got a plus 4y. Now remember that this minus y can be written as minus 1y. There's no number there. You can put, it's assumed that it's a 1. So minus 1y. So what we would type in our calculator is, since these are both y's to the first power, we would type in negative 1 plus our 4 right here, plus our 4 right here. So negative 1 plus 4 would be a positive 3y. And that's how they're getting the answer. Now notice that they took off the, right here they don't have it written as 1x because it's fine to write it just as x. You don't have to put the 1 in front of it. Okay, that's the end of Chapter 7, Section 2.